We are now going to be graphing quadratics in factored form. So factored form is exactly what it sounds like. It's already been factored for us. So we're going to go ahead and get right to an example. So y equals x minus 3 times x plus 3. And then we're going to go back to our table just like we did in standard form. And hopefully by the end of today, you will feel pretty comfortable with knowing exactly how to pick your x values, and we'll actually talk about that. But for now, we're going to help you out with them. So I'm going to go ahead and put -3, -2, -1, 0, 1, 2, 3. So what's going to be different is how you plug in these x values. So because there are two x's, you actually have to plug in that -3 into both. So for example, -3 minus 3 is -6, and -3 plus 3 is 0. Then you multiply. -6 times 0 is 0. -2 minus 3 is -5. -2 plus 3 is 1. So this would give us -5. -1 minus 3 is -4. -1 plus 3 is 2. So this would give us -8. 0 minus 3 is -3. 0 plus 3 is 3. So this would give us -9. 1 minus 3 is -2. And 1 plus 3 is 4. So this would give us -8. So again, what we just found right here is our vertex. And the reason that we can tell that is because it starts being symmetric about the vertex. So it goes -8, -9, -8. So we can kind of guess what 2 will be, but just in case we don't see it yet, if I plug in 2, 2 minus 3 is -1. 2 plus 3 is 5. So -1 times 5 is -5. And so we should start to see that it goes 0, -5, -8, -9. So then it will go -8, -5, 0. And just in case we don't see that, 3 minus 3 is 0. 3 plus 3 is 6. 0 times 6 is 0. Okay, so we will go ahead and graph this. And remember, you can pause if I'm going too fast, but you should definitely be taking notes on this. Okay. So we have -3, 0, -2, -5, -1, -8, 0, -9, 1, -8, 2, -5, and 3, 0. So once again, we have our lovely U-shaped graph. So just like we did last time, we're going to answer a couple of questions. So first is about the vertex. So the vertex is going to be 0, -9, because it's that point where the graph has a change in direction. And then we also want to find the x-intercepts. So the x-intercepts are where the graph crosses the x-axis, which happen to be at -3, 0 and 3, 0. And we could also see that by looking at our chart. It's when y is equal to 0. So x-intercepts are -3, 0 and 3, 0. All right, lastly, we have our y-intercept. So y-intercept is when x is equal to 0, or when it crosses the y-axis. So we don't see it, or we actually do see it in our chart. It's just also the vertex. So it's the point 0, -9. All right. Once again, we have the factors and then the x-intercepts. And they have a relationship, so I'm not sure if we're seeing that yet, but on this next one, hopefully we will. So this one we're going to do y equals x minus 1 times x plus 3. So again, I'm going to help you come up with your x values for your table. So we're going to choose -3, -2, -1, 0, 1, 2, and 3. And remember, we have to plug in those x's into both x values. So we do -3 times -1, or sorry, -3 minus 1 is -4. -3 plus 3 is going to be 0. So -4 times 0 is 0. -2 minus 1 is -3. -2 plus 3 is 1. -3 times 1 is -3. -1 minus 1 is -2. -1 plus 3 is 2. -2 times 2 is -4. 0 minus 1 is -1. 0 plus 3 is +3. -1 times 3 is 3. All right, we have found our vertex, so we can see that it is becoming symmetric about the vertex. So if it went 0, -3, -4, then it will probably go -4, sorry, this should be -3, and then we can probably guess that the next point will be 0, but we will check. 1 minus 1 is 0, and 1 plus 3 is 4, and that becomes 0. And so I'm going to go ahead and scratch those last 2 points. We don't really need them. And we're going to go ahead and graph this. All right, so I'm going to get rid of those and start our graph. Okay, so we have -3, 0, -2, -3, -1, -4, 0, -3, and 1, 0. Okay, so once again, our U-shaped parabola or quadratic. So first, let's talk about what the vertex is. So the vertex for this graph is going to be, again, that bottom point. So it's going to be -1, -4. It could also be on top. It just depends on which way the parabola is facing. The x-intercepts are where it crosses the x-axis. So we look at either the table or the graph. If you look at the table, you can see the x-intercepts are -3, 0, and 1, 0. So we have -3, 0, and 1, 0. And if you look at the y-intercept, you can see that it's when x is 0, or you can look at the graph and see it as well. So the y-intercept is 0, -3. All right, so this is where we need to figure out, well, how do I know what points to plug in? So one connection that we should be making is that if I were to solve for these factors, x minus 1 equals 0 and x plus 3 equals 0, then I would get x equals 1 and x equals -3. Now, what I just found was my x-intercepts, because in order to find an x-intercept, you have to make y equal to 0. Well, this tells us that if we have the factored form, we can find the x-intercepts. The other thing I want us to notice is, are we seeing any relationship to where the vertex is and where the x-intercepts are? We should notice that it's exactly in between, or halfway in between. So we look at that, halfway in between, and we can see here too that the vertex is halfway in between. All right, so if we were to just graph any function, I'm going to kind of give us steps to graphing a quadratic. Now, there's many different ways that we can do this, so I don't want you to get too caught up, but this is one way that you could do it. So step 1 is to put quadratic in factored form. And again, you should be taking notes as you follow along. And find x-intercepts. Well, the nice thing is, if it is given in factored form, we only have to find the x-intercepts. Step 2 is to find the vertex, or I should say the x value of the vertex by averaging the x-intercepts, because we know that the vertex is halfway in between. And then we can find the y value of the vertex by plugging in the x value. All right, so what that gives us is we would now have the vertex and we would have 2 x-intercepts, but if you listen to my last video, we talked about that it's good to have 5 points. So what you can do is, lastly, you can pick 2 x values below and above the vertex. Okay, so what we are going to do is now practice that. So we're going to do one last example and do it just like we said in our steps. So we have y equals x plus 2 times x plus 4. Okay, so step 1 is to put the quadratic in factored form. Well, it's already in factored form. So to find the x-intercepts, what we're going to do is set each of these equations equal to 0 because we want y to equal 0. So the x-intercept for this would be -2, and this would be -4. All right, so we have our x-intercepts. So the whole reason why we want to find our x-intercepts is because we know that the vertex is in between the x-intercepts. So we can average them. So this one's kind of obvious, but you add them together and you divide by 2. So -2 plus -4 is -6. Divide by 2 is -3. The only problem is I know it's -3 comma something. To get that something, you just do what we've been doing. You plug in your x value to get the y value. So that would be -3 plus 2. I'm plugging it into the original equation. -3 plus 4. So -3 plus 2 is -1. -3 plus 4 is 1. So it will be -1. From there, we are going to make a table. So I'm going to put in the vertex in the middle of the table. So I know the vertex is -3, -1. And then I'm going to pick 2 points above and below. So below would be -4 and -5. Above would be -2 and -1. Well, good news, we already know that -4 is 0 and -2 is 0. So to get the other ones, we know they're going to have the exact same value because it's always symmetric about the vertex. So we only need to plug in 1. I'm going to plug in -1 because it's a little bit easier. So -1 plus 2 is 1, and -1 plus 4 is -3. So we get -3 and -3. Okay, so then we go ahead and plot this. Actually, this should be positive. My apologies. -1 plus 2 is 1, and -1 plus 4 is 3. So these should both be positive. Okay, so then we will graph it. And I will change the color again. So we have -5, +3, -4, 0, -3, -1, -2, 0, and -1, 3. So again, if you want to graph a quadratic, you first need to find the x-intercepts. You can then average the x-intercepts to find the vertex, and then you can pick 2 points above or below the vertex, and that will do it.